Hi, this is Gopinath. Today I am going to talk about Jazelle acceleration by ARM. Why we need of Jazelle is that in Java is a platform independent, and it is due to its platform independent. It is widely used in many devices, many portable devices. But implementing in the mobile device is very difficult due to its costly. So we and in the execution of compilation of Java, it takes time and risk. For execution of Java in portable devices, we are using two acceleration techniques. That is, acceleration is done physically in the hardware itself, or it is emulated by the target device or by software. The software acceleration are widely used, but it is not suitable. Due to its costly, and some of the techniques, software acceleration techniques are JVM and JIT. In JVM, it stands for Java Virtual Machine. It is widely available for different platforms and different hardware and software platforms. It supports memory, and it provides high performance for high-end devices, but it can be provided if we use only the high processor. So due to so the cost cost is high, and the performance will be low. And the next one is JIT, that is just-in-time compiler. It bypasses the JVM process, and it executes the Java byte code, and directly convert the Java byte code into the machine instruction. So it is also costly. And the next one is hardware acceleration. Hardware acceleration is not really implemented because it does not increase the speed, and it is costly for devices, and the power consumption of the device will be high, and it also requires some extra memory. Some of the hardware acceleration techniques are dedicated coprocessor and Java coprocessor. In dedicated coprocessor, the Java byte code is directly executed in the processor itself, and in Java coprocessor is an Java processor that is compile the Java byte code into machine code. It may be reside inside the processor, or may implemented off-chip as an other device that can be connected to the processor. For this, we are going for Jazelle, and Jazelle is the combination of hardware and software that is used for Java acceleration. And in Jazelle, the ARM processor is execute the Java byte code directly within the processor, and this is used for multitasking Java virtual machine, and the performance compared to JVM is 80% increased. The starting time is also increased, and the Java acceleration is divided into two types. That is Jazelle DX and Jazelle RTC. DBX stands for direct byte code execution. In direct byte execution, the ARM processor execute the code within the hardware itself, and the starting time is improved compared to the JVM, and it requires no time consumption, and the implementation is very simple. In hardware,
what is the device they use to connect hardware and the ARM processor?
Multi-IC unit. And in previous hardware acceleration unit, it is not possible to implement the hardware acceleration in the existing OS and the existing hardware, because as the technology grow and grow, we cannot replace the device in the existing system. But in this JDBC, we can. It is very simple to implement. And the next one is Jazelle RTC, that is runtime compilation target, and it is a different technology using thumb that is derived from thumb to mode. It has some extra features like array based checksum and array based checksum. Array based checksum and null pointer checksum. And it allows the AOT compilation and also implement JIT compilation. AOT stands for head of time compilation. In AOT compilation, we can the code is compiled in 3 stages. That is while manufacturing the product. That is while downloading the code itself, we can compile, and during installation. In this installation, while installing the code, we can compile them, or in the first use of the application. While using the application, we need to compile, and these are the advantages of AOT and JIT, that is just-in-time compiler technology, combines with RCT. It was implemented in the year 2005, and DBX was implemented in the year 2002, and the software support for hardware accelerations. JRM provides some of the softwares. They provide solutions and innovation technology to solve performance and future requirements for compiling J2ME. They use the product like CDC and CLDC, that is connection device configuration and connection limited device configuration. In connection device configuration, they use the high devices like PAD desktops and high performance devices, and in connection limited devices like iPad and mobile devices and smaller devices. ARM is continuously working with partnered with many other handset developers and software developers to provide solution for the for continuously improvement in the software. The next one is JTEK. It is integrated within the JVM for advantages of DBX. This provides standard classes and library functions for compilation. And the JTEK 3 version is double to the rate of JTEK version 2, because they improve the performance by partnered with other software vendors, and there is no need of modification in the application or instruction set or in the program. And the next one is JMVM, that is Jazelle Mobile Virtual Machine. It is a product that is specially invented for the mobile handsets. It is used for Java acceleration, and it enables the developers for quick debugging, and it allows the network operators and the handset developers to modify the application to their developing community. And the ARM announced a license for Java and 3D graphic solutions to some of the organizations like Pantech, Apex, Innoworks, and Oxford Semiconductor, and Samsung, and more than 700 organizations. And the implementation, Jazelle is implemented as a new stage. It is implemented as an extra stage between the fetch code and the decode stage in the processor instruction pipeline. There are 3 stages basically in instruction execution, that is fetch stage, decode stage, and execution stage. In the fetch stage, the instruction is get and fetched for organized system pipeline, organized in order for decoding. And in the decoding stage, the codes are compiled or decoded to the native machine format. And the execution, the decoded codes are executed, and the result is given out. It uses basically the low-level binary transaction. Most of the codes about 90 to 95% of the codes Java byte code are compiled within the hardware itself. The remaining 5 to 10% of code are given to the Java JTEK for emulation by software. And the next is ARM ISA, that is ARM instruction set architecture. And instruction set is a computer architecture based on programs like programs that includes address modes, registers, and memories. Mostly ARM implemented in two instruction set. And the another one is Java instruction set. The first one is 32-bit ARM instruction set, and it is mostly used for executing normal instruction. And the second one is 16-bit thumb instruction set, and the third one is 8-bit Jazelle instruction set, and it is used for execute the compilation of Jazelle byte code, Java byte code to machine code. And ARM has 37 30-bit registers. It includes one PC and one PC register and one CPSR, that is current program status register. It is used to store the current status of the execution, so that if any error occurs or any reboot takes place, the state can be resumed and started. And it also has this 5 SPSR register, that is a saved program status register. It is used to save some programs so that it can be resumed, and further it is used later sometimes. It also has 30 general purpose registers that are used for various purposes. And the instruction set consists of it is a 32-bit instruction set. The first 4-bit consists of mode bits that are specified by the processor, used to specify the processor mode. And the next bit is an T bit. T bit is used to identify whether the processor is in what execution state. If the T bit is set to 0, the processor is in ARM state, that is used to execute normal instructions. And if the T bit is set to 1, the processor is said to be in thumb state, that is used for executing the thumb instructions. And the next bit are interrupt disable bits. The first bit is an I bit, that is used to disable the interrupt request, and the second bit is an F bit, that is used to disable the fast interrupt. And the next bit from 8 to 23 is an 23 bits are undefined bit. Those bits can be used used in future for some other purpose. They are not defined. And the next single bit is an J bit. It is used only in architecture 5TEJ only, and if it is set to 1, the instruction it is in a Jazelle mode, that is used for compiling the JDBC code to machine instruction. And the next bit is a Q flag, that is strictly overflow flag. It is also available only in architecture 5TEJ only. It indicates the saturation has occurred or not. And the next 4 bit are conditional code flags, that is N, that is NZCD. N is used for negative results, that is come out from the ALU. And Z is used for 0 result output from the ALU. C is used for operation that is carried out on ALU that carry out. And B is used for overflow in the ALU operation. That's all the things about instruction set. And the next one is application binary interface. The application binary interface is a low-level interface that is used interface between the OS computer programs and other programs. In Jazelle, it is used to as an interface between the JVM and the Jazelle hardware. It covers some of the things like data type, size of the data, and argument, alignments, and it is also used for call conversation. In call conversation, it defines the function argument, how the function argument passed to the processor, and also defines how the return value returned from the processor. And it is also used for how the system call will be taken by the application. There are basically two types, that is direct system call and procedural system call. In direct system call, the communication will be take place indirectly, and in procedural system call, the communication will be take place in procedure mode. And the next one is CPSR, that is current program status register. As I maintained already, it is used for maintaining the current status of the processor. It is indicated by the 2-bit, that is T-bit and J-bit. If the J-bit and T-bit are 0, the instruction it is in ARM state, and if J-bit is set to 0 and the T-bit is 1, then it is in thumb state. And if the J-bit is 1 and the T-bit is in 0, it is in Jazelle mode. If both bits are set to 1, then it is in thumb E mode. Because the bytecode are executed within the hardware in two stages, that is in ARM or that is in thumb mode or in ARM mode. And it can be switched between the hardware or software, that is Jazelle mode or ARM mode. The next one is BXJ, that is branch to Java, that is the name itself it identified that it is used to enter into the Java state, that is Jazelle state. It is identified by the J-bit. When the J-bit is set to 1, it is the Jazelle mode is changed. Based on some conditions, the Java byte code is executed. And the next one is architecture of virtual machine. It consists of basically three things, that is application mode, application layer, and execution layer, and the processor layer. In application layer, there are Java application that uses the resources like network graphics, remote methods, and native methods, and other things are native applications. Native methods are the things that native methods are the applications that are defined in other languages that are used with the Java application. And remote method are the remote method is the RME, that is remote method invocation, through which we can communicate to the remote systems for data transmission, data uplink and downlink. And the next one is graphics that are used to support for displaying the output and getting input through the graphical things. And next one is a network that is used for communication through network. And the next is standard Java environment, that is use of KVM and CVM. And KVM is a scaled virtual machine. Scaled virtual machine is a special execution environment that is developed for mobile devices. CVM stands for compiled virtual machine. It uses new technology, and this is developed for high-end devices. It uses like a verifier, class loader, program manager, and memory management. Verifier is used for verification and validation. And the next is a class loader. Class loader is used for loading the class files and library files that are needed for the execution of the Java program. And next one is a processor manager. Processor manager is used for manage the manage the execution of a processor, and it is used to maintain which process to be executed in which time. The next one is memory manager. Memory management is used for managing the memory depending upon the applications and users of users. And the next is Jazelle support code. In Jazelle support code is once the licenses get from the Sun Micros, now it was controlled by the Oracle. We can entirely use the technology of Jazelle in our needs. And the next one is the JTEK library guides, that is used to provide the libraries and class functions that are used for the execution. And the last one is the Jazelle acceleration ARM processor, that is the processor that is used for directly execute the Java Byte Code into machine code. And the next one is the architecture of ARM V7. It consists of a ETMA interface, a co-processor interface, byte bus interface, and the processor. The processor is a general processor, combines of Jazelle technique and NOR processors used for normal execution. Jazelle used for converting byte codes into machine codes. The ETMA interface, that is an ETM stands for embodied trace macro cells. It is used as an interface between the ETMA devices and the processor. The ETMA devices are used for tracking the data of processor. And the next one is the co-processor interface. The co-processor interface is used for communication and data transmission between the processor and the co-processor that are defined outside the processor. And the next one is the bus interface unit. The bus interface unit is used to connect the processor with the peripherals and other devices that are connected within the system. It is used to transmit data in and out to the processor. The next is the applications of Jazelle. Applications of Jazelle. Jazelle is widely used in wireless communication, satellite communication, and home gateway communications. In wireless communications like phones, laptops, in laptops like Google Chrome OS, and in phones like Docomo Phone, and in home gateway like Blu-ray players and other home appliance devices. And it is really classified into wireless, home entertainment, home automation, and automotives. In wireless communication, it is used for hardware. It is used in mobiles like mobiles, iPads, and PDAs. And in home entertainment, it is used in set-top box, gaming devices, and TVs and HD TVs like. And in home automations, it is used for building management units and cooling and heat appliance for like micro ovens. And the advantages of Jazelle modes are in three types, that is direct execution in hardware, interrupted in software, and undefined byte code. In direct execution in hardware, mostly about 90% of Java byte code are compiled, and it is common and simple to implement comparing to the JVM. It reduces the interpretation, and there is no need of JIT, that is just-in-time compiler. And in interpretation in software, if the remaining codes that are not compiled in the hardware is translated to the software, those are compiled in the software. The starting up time is higher comparing to the JVM. It reduces the complexity. And the undefined code. The undefined code are the code that are unknown or handled by Jazelle as for it will intimate the error or it gives an exception. And the next is It is widely used in new technologies like Moto Vista is a company that provides an mobile Linux 5 software OS that is based on Linux 100%. 100%. It is used for mobile devices that uses Jazelle technology, and in automobile devices, automobiles, the Artica is a company that provides an Artica GT in car that is that uses a dual dashboard display. It is based on Jazelle technology. It uses a graphic controller like Fusco MB86 ROA, and in Samsung they are using Jazelle technology in Blu-ray player that is BDP1000 that is used Java DB, that is an distributed Apache Derby database. It is used. Supports it supports like ANC, ISO, and SQL. It also supports JDK. And in the last one is Apex and Docomo companies are collaborated to form an mobile handset that is an Fuma 900i that is specifically designed for Indian users. It uses Java ME technology, that is Java Micro Edition. It was developed by Java community processor. It uses MIDP and IMP. That is MIDP stands for Mobile Information Device Profile, and IMP stands for Information Module Profile. MIDP is a subset that is derived from Java ME. It is used for controlling GUI and interfaces, and IMP is a subset that is derived from MIDP, and it is used for controlling the interface in the devices. It needs an 128 KB for Java platform, and 8 KB for data, and 32 for running environment. And the features of Jazelle are high efficiency and low cost, low power consumption, and no duplication of chip memory, and it supports all platforms. And that's all the things about Jazelle. Thank you.